Thanks everyone for having me. Really excited to be here. What a privilege and honor it is to be talking to you all about how we do component testing at Cypress. So as Jess just kindly introduced me, my name is Lachlan, and I've been at Cypress for about 2 years working on component testing. And outside of that, working on various things in the open source JavaScript testing ecosystem. Worked on a lot of tools over the years, but Cypress is definitely my favorite one. And I'm going to be showing you how we have been using it at Cypress. So we're going to attempt to answer a few questions before the end of this presentation. The first is, you have end-to-end tests. Why do you need component tests? The second is going to be who is going to be writing component tests, or at least who we found writes the most component tests here at Cypress. We'll then talk about when you might write some component tests. And finally, I'll go through some examples showing some of the tests we're using at Cypress and how we used it to launch a new feature. So the first thing you have to ask yourself is, why am I even spending my time to write all of these tests? And I would say it's very similar to a lot of the kind of current popular component frameworks. They emphasize modularity and isolation, so creating reusable, self-managed components. And these frameworks really encourage that philosophy. And Cypress has a very similar philosophy around component testing, which is small, isolated tests. The more focused your test is, the easier it will be to debug. This is very similar to what you might think about with a unit test. You're going to find out faster if there's a problem, and it's going to save you a lot of time when it comes to debugging. Of course, end-to-end tests are very useful as well, and they will tell you if something is broken, but they're not always going to tell you where to look and how to debug it. Component tests are on the other end of the spectrum. They're much cheaper and easier to write, and often faster to iterate on. Next slide. So if you've ever been to any sort of webinar or presentation about testing, you inevitably see some sort of testing pyramid. On the left, you see the kind of traditional one we used to have when applications were a little bit more simple. As things became more complex and abstracted, we've added more layers to this pyramid. And it turns out component testing fits into this right above unit tests, but generally below your integration tests. They're going to be a little bit more broad than a unit test, but they're not going to fully integrate your entire system. Still very useful though, as you're going to see. So one thing that I've noticed is very different when it comes to component testing when compared to something like end-to-end testing is the actual time you go to write these tests. Traditionally with an end-to-end tests, you're going to write these towards the end of your development workflow. Often these are written by quality assurance engineers or during testing, acceptance testing. I found with component testing, they're a lot more useful earlier in your development workflow, often during prototyping, exploration, or even when you're just looking at different ideas. The fact they're so cheap and easy to write makes them a great tool for exploring and iterating, and you can throw them away without feeling like you've wasted too much time. As such, the people writing these tests often changes as well. With your end-to-end tests, you often have people like product owners and QA engineers architecting these tests. We found at Cypress with our component tests, it's more developers and UI engineers, so people working more early in the product workflow. So now that we've taken a look at those questions, I'm going to walk you through one of the features we launched recently at Cypress and talk about how we use component testing for a few different parts of this development workflow. So I'm going to be talking about a feature called the debug page, which I'm going to show you in just a moment. There was quite a number of challenges building this feature. So we had a pretty ambitious deadline. We were also doing a lot of design and development simultaneously. Since we weren't exactly sure what we wanted, we were using our feedback from our internal product and our ambassadors to drive the development of this feature. It is a fairly complex interface, and we had to integrate both Cypress Cloud and the Cypress app. So there are a lot of different moving parts here. So this is a debug page for anyone who may not have seen it. And this is something we're going to talk about a little later on in the webinar as well. Basically, this is going to be a real-time page linked up to Cypress Cloud. And whenever a test fails, your interface is going to update, and that's going to let you debug more quickly and effectively. You can see this is a fairly complex interface. There's quite a lot going on. We have a whole bunch of different layers of components, and each one of these needed to be developed from scratch. So there's a lot of complexity here. In addition, we wanted to make these components reusable. Since we are going to be building out our offering in the future, we're going to have many different features, often taking advantage of similar components. So that was another focus of this particular feature, not just to build this feature out, but to enable future features as well. So I'm going to just jump into the code and show you some examples. We're going to start with a very simple component, and this is the debug run navigation limit message. You can see an example of it on your screen. There's only two different states. The first one says we found more than 100 runs, and the second one says we found more than 100 runs. Go to Cypress Cloud and see all of the runs. Basically, this is just going to inform the user if there's a very large number of runs for a specific branch and how they can go to Cypress Cloud and learn a little bit more about it. Just going to switch over to my editor now. The first thing I'm going to do is actually run this test just so you can see what it does. And here we go. You can see it is very simple, just this one line of code here. And depending on some variables, we're going to show something slightly different. In this case, we're going to have an extra message. Let's go ahead and take a look at the test. So you can see here, this is about as simple as a component is going to get. There's very little logic. It's basically just going to be a conditional. The first thing we're going to do is use SciMount and go ahead and mount our component, passing in the correct props. After doing so, we're going to go ahead and make an assertion. We're just going to go ahead and use find by role. And this is one of the more powerful things I've discovered when doing component testing here at Cypress. We're actually using the Cypress testing library, which comes with a number of built-in accessibility selectors. And this has allowed our application to be accessible first right out of the box. And as anyone will tell you, doing accessibility as you develop is much, much easier than retrofitting accessibility onto an existing application. There's not too much more to say about this test. I think it's fairly straightforward and simple, but it does illustrate how little code you need to write a very basic component test and get quite a bit of functionality here. We're going to now head on to a little bit more complex test and see what happens there. So the second test we're going to talk about is the debug pending run count component. And this is the one up here inside of this red box. You can see we have 210 out of 211 specs completed here. And this is something that's going to be updating real time as your runs are continuing in your continuous integration provider. Let's head over to that test now and have a look. Again, the first thing I'm going to do is run that test. And it is very simple again, just some text. We also need to consider what happens if there's no data received. And this can happen in the case of, for example, the test hasn't started running yet, and we're going to receive an undefined value. We don't want to just show nothing on the screen. We want to give the user some information, such as 0 out of 0 specs are completed. We can see again, this is a fairly simple spec. We are again going to use SciMount and just going to go ahead and mount our component. And then we have a single assertion. This is very similar to the previous spec. I think it's just good to emphasize how simple some of these specs can be, but just how useful they can be as well. Just with a single test, we're not only able to mount our component and make an assertion, we also have a little environment here where we can go ahead and develop our interface. We can change the color and the size of a text, and this can be a very useful design tool as well as something to write tests. Now we've seen a few very simple examples. Let's go ahead and see something a little bit more complex. So this is going to be a component called debug run states. This one's a little bit more complex for a number of reasons, primarily because we have to handle a lot of different cases. So for example, if all your tests are passing, we're going to go ahead and say, well done. Alternatively, if the user has reached their limit of tests, we're going to show an error message and prompt them to contact their administrator. And we also have to handle a number of edge cases where things go wrong. For example, the run was canceled, the run was incomplete, or any other number of unexpected use cases. Let's go ahead and take a look at that test now. So as before, I'm going to go ahead and run this one. And we can see there are a lot more cases to be tested here. So there's quite a bit more complexity. And that is going to be reflected if I go over to the spec file and take a look at what's happening here. So one thing you'll notice is we're actually importing a number of components here. A component test can be used for one component, or you can exercise many different components at the same time as well. This component represents all of these different states, which are inside of very modular components. And that's why we're importing so many of them here. I have seen some users prefer to have a single spec per component, but in my experience and working here at Cypress with a very large code base, I found it's completely fine to have multiple components imported into a single spec, just to have everything in one place. This is just a personal preference though. Either way, we can go ahead and take a look at this one and see these components tests, although more complex, are actually very similar to the previous examples we saw as well. We're going to start off by mounting our component and then just go ahead and make these assertions. If we scroll down a little bit, we can see they get a little bit more complex. One thing we found very effective is to use context just to make it obvious what part of the user workflow that we are asserting against. Since when we have a very large number of tests, the files can get a little bit confusing. Either way, you can see the tests are very simple. We tend to just use contains, and we're not using any, we're not testing any implementation details here. We're not finding any specific components by name or ID. We're simply asserting what should be on the screen. And this reflects what the user does. The user is simply going to look at their monitor or their screen and read what they say. And that's kind of what these tests are reflecting here. You can see these are quite long, but there's not too much more to say here. So what we're going to do is move on to the final test, which is going to be quite a bit more complex than this. So far, all we've seen are very individual or modular components. So these are very simple to test. In practice, you see a lot of tutorials that show these very simple tests, but a lot of them don't go very far and show more complex ones. So that's kind of what I'm going to do here with this very final example, the debug container. So this component basically represents the entire page. So instead of just using a component test for a modular part of the application, I'm actually going to mount what is effectively an entire page and use that to integration test all my components to make sure everything is displaying correctly. There are a number of benefits to this. Sometimes you have components that look different when they're composed into larger, more complex components. So I'm able to assert everything is looking correct here. And as you see, I'm also going to show you how we can explore a bit of a user journey using a component test here as well. Let's head over to debug container now, and I'm going to go ahead and launch this. Just as a note, I'm only going to run one test because this is a fairly interesting example I'd like to share with you. So you can see quite a bit is happening in this test. I'm just going to go ahead and run it again. Instead of just rendering like some of our other tests, it's actually quite complex. It goes ahead and, as you're going to see, it mocks out some GraphQL requests and follows the user journey of waiting for a test to finish, receiving the information from Cypress Cloud, and updating the user interface correctly. This was very powerful. I was able to write this before the endpoint even existed, so I wasn't blocked by another team, which is often the case with some end-to-end tests. Let's go ahead and take a look at the code. So we can see the first difference here is I'm not using sci.mount anymore. I'm using sci.mountFragment. And this is a custom command I'm going to talk about in a little bit. Basically, this component is using something called GraphQL, and that is going to allow us to fetch data from our Cypress Cloud. And part of that, or part of using GraphQL, sorry, I'm just going to show you how this works right now, is you declare your queries in line like this. And these are called fragments. And there's going to be a number of these that compose together. The one thing we learned here is basically, if you're going to write a complex component test, much like a complex end-to-end test, you do need to spend some time and invest in your infrastructure. And that's what we have done here. We need to be able to orchestrate a test depending on the fragment and the data that comes back from the API call. If I head back to my spec file now, you can see I'm using mount fragment here. And this is analogous to the fragment I'm talking about over here in the debug component. If we head back here, you can see I'm passing mount fragment. I'm specifying the fragment, which is going to be the query. And then we have the variables. And finally, we have this onResult function. We're going to receive what is a mock API request. And then we have another opportunity to modify the data inside of here. Previously, in one of the complexities we encountered at Cypress was we had a lot of fixture data and the fixtures were not always clear. It was very hard to understand what data was coming and where it was coming from. By adding this onResult function, we're able to manipulate and change the fixture data here. And by doing so, it makes very obvious which fixture data is going to be used inside of your test. And you can modify it all here inside of one file, instead of going to another file in the code base and trying to figure out what's happening. Finally, we have our render function down here, and this is where we do the equivalent of sci.mount. We're returning our component and we're passing in our GraphQL value. The test is then a little bit more complex. If we scroll down, we are still doing the usual find by test IDs, and we have to wait. Normally using sci-wait is a bit of an anti-pattern because it makes your tests slower, but I found this very useful for a number of reasons in this particular case. The main reason I found this useful was I was able to assert against the UI and watch the actual spinners loading, and this is kind of an acceptance test as well. We could take a screenshot there or record a video and make sure everything is correctly updating when the user interface is loading or in a failed state. Finally, if we continue on, we can see this test is fairly long and complex. And the reason this test is longer and more complex than some of the previous ones is we're no longer testing an isolated component. This is much more representative of a user journey. It's kind of in this gray zone between a component test and an integration test. But I still found this was very useful during development. And this is a very powerful tool we used while developing this feature. The main lesson here is that component testing is very flexible. You can use it for a tiny little component, or you can actually mount almost an entire application and use it however makes sense for your particular workflow. I did find writing these longer tests was a good way to exercise the entire workflow, and I found it very useful. Let's go ahead now and take a look at the most complex part of this, which is the custom mount command for mount fragment. It's going to scroll back up here. Just to clarify, I'm referring to this mount command here. So here's my mount fragment. It takes a bunch of options, and you can see it is fairly complex. We go ahead and make a test client. This is kind of like a mock GraphQL client, which we're able to modify and change the data that is returned from it. We then have our various setup for our actual component, our plugins, and that includes things like a router, for example, or maybe a store. And then we finally continue down and do our mount. So the majority of these custom mount functions are going to ultimately call mount, but you're going to do a number of things to set up for your component first. Some other common patterns I've encountered are things like mount with router or mount with store. So the main takeaway here, and the thing we learned at Cypress, is we need to invest heavily in creating the correct custom mount commands, which allow us to represent how our component is going to behave in a real application. This made writing tests very easy, and by making it easy to write tests, it encourages developers to do so. I think the key to succeeding in any sort of testing capacity is make it so effortless to do that it's actually easier to write tests than not to write tests. You can see there is still a bit of complexity here. We had to TS ignore because the types do get fairly complex, but this is still a work in progress and something we're constantly working on and improving. So this is a link to a bunch of resources. All of the code I showed you actually comes from the Cypress code base. You can go ahead and take a look. If you have a copy of these slides, you can actually click on the component here and it will take you to the actual code base as well. That's these ones here. So you can take a look at the exact tests that I've been talking about, and you can even run them locally as well. That does bring me to the end of this part of the presentation. So I think we'll hand it over to Jess to manage some of the questions, and I'll take any questions at this point anyone might have.
Hey, Lachlan. Thank you so much for that. That was awesome. Yeah, I'm going to manage the question part.
Sure.
So hi, everybody. I'm Mark. A couple of questions came into the Q&A. I think you touched on these topics as you went in there as well, but maybe you'll be able to give a bit more of a high-level summary. The first question is, I love component tests, but what if devs want you to check multiple components together? What is the best approach? So you've showed several different variations on that. Do you have recommendations for the approach to test kind of multiple components together?
You mean, sorry, can you clarify the question? I'm just having a look at the Q&A right now. So you're saying that you want to write tests that have multiple components composed together? I think I understand what you're saying. So one example I've found of this when working on Cypress is we have a number of form input components. We have like an input, a text box, a radio button, a select, and people want to write a test with all of those and create a form. So the main thing I've done there is just created a new component inline inside of my test. My screen is still shared, so I'll just go ahead and show you how I would do this right now. One thing we've found pretty useful is even just inside of a test. So something up here, I might just go function my form. And let's say this is just a brand new component. It only exists in the context of testing, not in my code base. Let's just say we're using React, which is a pretty popular way to write an application. I might have a form component, which I've imported from some other file. Then I might have an input component and so on and so forth. I've often created these little test wrapper components, and that's been a pretty good way to compose components together and see how they would behave if they're used together. In addition, you can go ahead and have state here as well. So you might have const count is equal to use state, something like that. I'm not sure if this is exactly what the question was asking, but I would say you shouldn't be afraid to invest in creating these kind of wrapper components. It's very similar to how we created our own mount fragment function. We're basically investing in infrastructure to facilitate writing better and more useful component tests.
I think that's a very helpful answer. Thank you. It looks like Murat has given some other thoughts in text as well in response to that one. The other question is in here is, what is the best way that y'all recommend to mock data for the components? So you gave an example of GraphQL, which is kind of a fairly specific use case. Any general advice on mocking data for component testing?
Yeah, sure. I think it would depend on what you're mocking. In general, I try to mock the lowest level. So what I mean by that is, let's say you had a component that was using a GraphQL client, and then or a HTTP client, and then you're going to fetch some data and render it on the screen. You have a few options, right? You could just pass the data as a prop and then render that on the screen. And that way you completely bypass the need to even interact or mock data. If you do that, though, you're going to miss out on testing all that other code, for example, related to sending the request. Maybe you want to assert that the correct authentication header is set. You're going to miss out on that. So what I would generally do is try to mock the lowest part of the stack. In this case, it would be the actual network request. So I would try to use something like sci.intercept to intercept that data. In general, I probably recommend using sci.intercept where I can in component tests. You can definitely use a real server if you want, but I found that makes my tests, it takes a lot more time to set them up because you have to spin up a server. And that's kind of thing we would do in an end-to-end test. So I generally would recommend for at least fetching data, I would use sci.intercept, or even combined with Cypress fixtures, that can be a pretty good way to handle that sort of thing. Hopefully that answers the question. Definitely have more thoughts, but we can maybe talk about it in Discord afterwards as well.
Yeah, these are great questions to follow up on, maybe also in the ambassador chat towards the end as well. I have one more for you, and we'll finish with this one. This is, can we implement test-driven development using Cypress component testing? And in this case, how do we do that?
Good question. So you can do anything with any tool. No one's going to tell you what to do. Don't let anyone tell you what to do. But I have had a mixed experience when doing test-driven development with component testing. I find that unit test-driven development works very well for unit testing, where you have a very well-defined output and input. So let's say you have some data you need to transform. That's a really good use case for test-driven development because you know exactly what you're building. I found with component testing that is not always the case. A lot of the time, I'll build a component, do some styling, we'll discuss it with product and design, and it turns out they actually want a different color, a different size, a different something. And then test-driven development didn't really help you too much there. It can be useful for certain things, like a component must display some information. But in general, I found the workflow I've used and my colleagues at Cypress have generally been using is we have developed the component just with a very basic function. So for example, you start off with something like scimount. You have your Cypress running and you iterate on it. And then once you're happy with it, you write your assertions and usually call it a day at that point in time. So to answer your question, you can do unit testing with component-driven development, but in general, I find it much more better to do I guess, visual development testing, where I see what I'm writing, I'm iterating on it constantly, and then I will generally write my assertions towards the end.
Okay, cool. Lachlan, thank you very much. Really appreciate your time and the preparation for that. It was so cool to see all of the internal details of this feature and watch the spinner going and see the test moving through over time. Yeah, that was absolutely fantastic.